Welcome back. Let us continue the same chapter, that is gravitation. We understood that the earth attracts objects due to gravitational force. Whenever the objects fall towards the earth under the gravitational force alone, we say that the objects are in free fall. When the object is falling towards the earth, there will be no change in the direction of motion. But due to the earth's attraction, there will be a change in the magnitude of the velocity. And any change in velocity involves change in acceleration. This acceleration is due to gravitational force. Therefore, this acceleration is called the acceleration due to gravity. It is denoted by small letter g. The unit of g or acceleration due to gravity is same as that of acceleration, that is meter per second square. We know that according to second law of motion, force equals to mass into acceleration. We know that the acceleration in falling object is due to gravitation and it is denoted by g. So let us replace a by g. It gives F equals to m into g. Force equals to product of mass and acceleration due to gravity. From universal law of gravitation, we know that force equals to g into m by d square. Substitute the value of F here, that is m into g equals to g into m by d square, or we can write g equals to g into m by d square into m. Here m and m it cancels, so we get acceleration due to gravity g equals to m by d square. Here m is the mass of the earth, d is the distance between the object and the earth. Let an object be on or near the surface of the earth. The distance d in the equation will be equal to r, that is radius of the earth. Therefore, mg equals to g into m by r square. Again, g equals to g m into m by r square into m. Again here m and m get cancels. We get g equals to g into m by r square. Since the earth is not perfect sphere, the radius of the earth increases from the poles to the equator. The value of g becomes greater at the poles than at the equator, and the value of g will be more or less constant on or near the earth. Now we will calculate the value of g. To calculate the value of g, we will take the equation, that is g equals to g into m by r square. Here let us substitute the values for g, m and r. Capital G is the universal gravitational constant, that is g equals to 6.7 into 10 to the power of minus 11 Newton meter square per kg square. M is the mass of the earth, that is m equals to 6 into 10 to the power of 24 kg. And capital letter R is the radius of the earth, then R equals to 6.4 into 10 to the power of 6 meters. Let us substitute, that is g equals to 6.7 into 10 to the power of minus 11 Newton meter square per kg square into 6 into 10 to the power of 24 kg divided by 6.4 into 10 to the power of 6 meters whole square. By simplifying, we will get 9.8 meter per second square. Therefore, the value of acceleration due to gravity g equals to 9.8 meter per second square. Next, we'll move on to motion of objects under the influence of gravitational force of the Earth. Let us watch this video.
Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest.
This experiment is conducted in the normal room. Here, the ball and the feather dropped simultaneously from the certain height. We observe that the ball reached the ground first. This happens because of air resistance. The resistance offered by air on the feather is more than the resistance offered to the ball. Let us watch one more video. In this video, the experiment is conducted in the vacuum chamber. Here, air has been removed out from the room. Again, feather and ball dropped from a certain height. In this one, both reach the earth at same rate. We know that the object experiences acceleration during free fall. The acceleration experienced by an object is independent of its mass. This means that all objects, hollow or solid, big or small, should fall at the same rate. As g is constant near the earth, all the equations for uniformly accelerated motion of objects become valid with the acceleration a is replaced by g. The equations are v equals to u plus at, s equals to ut plus half at square, and v square equals to u square plus 2ac. Next we'll define what is mass. In the previous chapter we have learned that mass of an object is the measure of its inertia. And we learned that greater the mass, the greater the inertia. The mass of an object remains same whether it is on the earth or on the moon or even in outer space. Now we'll see what is weight. We know that the earth attracts every object with a certain force, and this force depends on the mass m of the object and the acceleration due to gravity, that is small letter g. We know that F equals to mass into acceleration. That is F equals to mass into acceleration due to gravity. That is F equals to m into g. The force of attraction of the earth on an object is known as the weight of the object. It is denoted by capital letter W. Replacing F in the equation F equals to m into g, we get W equals to m into g. The SI unit of weight is Newton. Thank you. Happy New Year in advance.